We're
Good
live.
morning.
We're live. Welcome to Live at Loop. What's up? It's David Nichols. I'm the CEO of this company, and I talk into cameras about cool robots. So welcome to us doing that. Hope you enjoy. I have with me Mr. Jonathan McLean, concept engineer. Jonathan, welcome.
Thank you.
Nathan Shank, another brilliant concept engineer here at Loop. We are working on a new machine concept in our first season of Live at Loop, and that is our process by which we take some interesting problem or opportunity in machines, and we take a bunch of tricks from our bag of technologies and 10,000 other little weird things that we've learned over the years and various other cool toys. We combine them into this idea of a machine of the future, and then we go off and build it. But point is, first get together with the concept, dig in, explore around, and we're kind of midway through the season. We're getting ready to wrap things up. So what that means is, in another week or two, we're going to be delivering what we call a pitch meeting. That's here's this machine of the future that we've investigated. Here are all the parts. Here's kind of what it would take to build it. Here's the architecture of it, and we're working with Jonathan and Nathan today to say, hey, what's left to do here? What do we need to do to wrap this up and bring it in for a nice smooth landing? So I've got an agenda here. We're going to hear from Jonathan first. He's been looking into some stuff related to the timing and layout studies. He tells me that he has some graphs that have lots of colors. I love colors, so let's rock on that. Um, I've got the screen share. Jonathan is going to share. Look at those colors. A lot of colors. Just as he promised. Okay, cool. Jonathan,
Well, I think
welcome to this. What's up?
this kind of speaks for itself, right?
Yeah, totally. Are you alone in the room with it?
I don't know how this could be any more clear, but here goes. Um, this chart right here is the position of 30 shuttles over time.
Let's X that Excel update. That's my Excel. Sorry, we got screens on screens. Okay, sorry. Please
It
continue.
just so happened that I also had Excel up.
Yeah. Okay.
Um, yeah, so this graph, each of these different colors represents a shuttle. So this chart is a position of a shuttle over time. So this chart is sort of that original concept where we had 30 shuttles and we had a track that was two 180 segments and two straight segments along the side. And so you can kind of see how the shuttles are close together at times. And this is a rollover situation. So this is actually a continuous move down here, but it rolls over as it hits the max of the perimeter of the track. So this is one continuous move here. So they're close together, and you can see how they kind of have this move, this region here, where they are.
It's not steep.
It's not as steep, and they are.
Slower.
And it's lower, and they're also not. It doesn't seem that they're quite as tight here. And then it's one more region um, where it's pretty steep, and the shuttles are further apart. So, and you can kind of see in the cycle here how this happens. So if you're looking at, oops, never mind.
I can see where they stop. You can see in these sections two, two, and two. There's pairs that are sitting
Exactly.
picked up.
Yep. So there's
It's exactly this amount of time.
yep.
Yeah.
And if you look at the chart below, this is not labeled, but it's the state of the robot, where this top region here is when the robot is doing a place, so it's actually placing product into the cases. This intermediate step right here, which is one, that state is for picking, and then the zero state down here is when the robot is idle. So the goal is really to, if you're trying to maximize throughput for the system, the goal is to minimize this region right here. Try to annotate here.
Oh, sorry. Hold on. Audio is doing robot choppiness. Okay, so let me just. Yeah, just a second. Bear with me for a second because we also just had a Zoom failure. Because Microsoft is also updating. Okay, so I'm gonna play around on my screen, and I just don't want to show that. Okay, let me yeah.
This is so great about going live. You just don't know what's going to happen.
That's right. Okay. Now I'm gonna get rid of that. Okay, so
Cool.
Jonathan, your screen is back up.
Great.
Give me a second, and let me just look at the audio for a second. So.
I'll be practicing my annotation methods. Ooh, oh, not blue on blue.
You good? I mean, what does it sound to you?
Nah, we got to do
he's listening to it remotely. Okay, cool.
DNR orange.
Let's try that again.
Thanks, Glenn, for the heads up.
Yeah,
thank you, Glenn.
Appreciate it.
All right, cool.
Cool.
Tell me more.
Sure. So this chart down here is the state of the robot. I don't know how much of you heard that in my robot voice, but
Just go full speed.
all right. So top is placing, middle is picking, bottom is idle. So if you want to maximize your throughput, what you want to do is minimize these idle regions. That's one observation I found out. This chart on the right hand side is not quite legible, but this is for the 25 shuttle situation. So we actually took out 5 shuttles and we changed the length of the track. Notice there are some position jumps in here. It's my fault. Those are software bugs. So just imagine that this is compressed a little bit to where it doesn't go around the perimeter of 5 point something meters. It's more like 4 point something. Yeah, that's really the main takeaway.
It's when the screen shares up. Okay, cool.
So one thing I noticed about that is one of the right things are spread out is that the shuttles are better utilized, like they're actually more often. Well, I think it's just I'm not sure that they're necessarily spread out more. I think it's just like you can see where the rollover happens in a region where they're doing like that first move to the robot area where they're more spread out. I think it maybe makes it look that way, but they still have those regions of where they're really tight there.
Yeah.
I think what I've found is for all intents and purposes, the cycles are really, really close. You can tell by looking at the robot state data down there at the bottom. They look pretty much identical, which is good news because if you can cut out 2 large segments of track and some shuttles in there, that's a chunk of change with no real penalty to throughput. So I think if these were phased correctly and without the position jumps, I think you'd be able to see that the cycles look really, really close.
Yeah, but a lot shorter and a lot less shuttles.
Fewer shuttles, fewer segments. And there was one more study I meant to do right beforehand, which would be interesting, which would be to see how much wear is put on the shuttles versus a shorter track versus fewer. So you have more cycles per shuttle, but less travel per cycle. So that should be a quick.
I'm gonna have to play that back in the recap to fully get it, but I believe you. Okay, so this looks awesome. When we clean all this up and put them on the same scales, we'll be able to. What I love about this is being able to see the whole sequence, all the shuttles all the time. This is a really cool chart, and if we keep working on this, it'll be able to see like where the bottlenecks are and where we can improve things. This is really awesome. So. Okay, so one of the conclusions that I heard you say was shorten the track, and I think we should take a minute to share the CAD that we were playing around with the shuttle layout. I played around with the model that Nathan is going to show up on his computer, and I can talk about it just briefly. Jonathan, if you want to unshare, and Nathan, you share, let's do a quick screen swap.
All right, stopping share.
The show must go on. Great work, guys. Okay. So we're looking at a top view of the shuttle layout. And in all of our concept drawings, if you were following along before, if you were following the introductions, the infeed area would be in the middle of this image, kind of horizontally, and the robot pick and pack area would be below or towards the bottom. So one thing you'll notice from our previous images is that we have a new loop on here, and I'll talk about that in a second, but what I want to share is just this track section is now shorter and hits the same amount of throughput, which is really, really beneficial. So we talk a lot about the flexibility and the power and the speed and all this acceleration, the dynamic performance of tracks. They do that by having lots of little motor coils and very fancy electronics inside them. So always optimization is thinking about like how can you make the track as short as possible to achieve the concept of the machine, because it's a huge factor in the economic model. And so we have a shorter track here. So Nathan, if you want to just fly us around, I'll talk about the reason that we put a short loop on the outside. The reason that we put a short loop on the outside is because we were imagining, and there's been a lot of discussion on the infeed, what if we miss a pick? What if we have a shuttle that comes through and it doesn't get a product, or there's some kind of shenanigans that happens where a shuttle is in the middle of its convoy and it's not what it's supposed to be? You got to get that out of there, otherwise the robot's going to miss pick and there's going to be a problem. So what we have here is kind of a decision point where if there's something about that shuttle that we don't like, or we sense that the pick didn't go properly, we can shoot it off on the divert track and it'll get out of the way. You can still have a full stream, unbroken stream behind it, and when that shuttle comes back around, we can tuck it in between a complete pick and kind of get it through the machine, so that we're not putting holes or gaps into the area where the robot's going to pick. With the shuttle, it's they can't, otherwise you can't change the order, and so we figure out that gives us a lot of flexibility. Also for servicing, we can take shuttles out of circulation and put new shuttles back into circulation without ever stopping the machine when we have this kind of divert loop. It's costly to do that, like I said, for the reason it's more track, but we think it'd be worth it in terms of the machine, and ultimately work out in the payback model. Final thing to add on that, Nathan, if you could switch the visibility on this, because we had another concept where instead of diverting and coming in a complete loop, we could also just divert and go off an off ramp. So this is a case where we said, let's just put a 90-degree shuttle on here. We'll be talking about it more as we build in the simulators, but this is a possibility for, again, reducing the track length, reducing the cost, but still having a lot of the same features. The downside of this approach would be any shuttle that diverts would then have to back into the track and then go forwards, and so it might not be the best, or that might not work out in terms of our throughput studies. It just depends on how do we want to get that thing back into circulation, and we'll answer that question by building models and by building simulations of the real machine that can answer those questions. It just occurred to me also we could put a 90-degree on this is the off ramp, but if we put a 90-degree on ramp, it might also be shorter than a recirculation loop. Anyway, that literally just occurred to me. But okay, so this is our track layout. Does anybody have anything they want to add about this, or any other thoughts?
Nathan, can you annotate, just for our viewers at home, kind of where like the robot portion, like the robot section would be versus where the infeed would come in?
So this is where the robot is, and then this is the infeed section here.
Yeah.
So cases come in this way.
Product.
Product comes in this way, and then goes around the track once it's on the shuttles, and then gets picked by the robot, and then goes onto a case conveyor over here.
Yeah, we'll talk about it for the follow-up, because next week we want to be doing the complete presentation of here's the machine, and I think this was just me playing around with CAD with the track sections just to get the layout roughly correct after we heard from Jonathan that shorter would be better. And so we'll build a model of this that has everything completed that we can put into our presentation deck for next week, and that'll clear that up. And I'm interested too to get some of our infeed concepts and the robot and like a complete picture of the machine. That's always really cool to see and really helpful to help people see really what what it is instead of hand waving and scribble annotating. Having awesome CAD of what the machine should be like is it really helps people understand. If you haven't been thinking about it for 50 or 100 or 500 hours like we have, then it helps to see it when you come into meetings. So, okay, that is CAD. Do we want to talk any more about CAD before we move on to a donut break? We can come
One
back
thing that I
yeah, go ahead.
one thing that struck me on this is just how small this this system is.
Mm-hmm.
I mean, this we can measure like from, let's see here, we'll measure from that hole to this one. That was 1800 millimeters.
Can you pull open pull in that drawer and pull out the fancy metric tape measure only that I have? Yeah, there we go. Okay. So here, you get me 1.8 and we'll show it on this camera.
That's it.
It's about my wingspan.
Yeah.
1.8. So here we go. The track loop is that long. Am I on frame? Am I have the whole thing in frame? A little lower?
Mm-hmm.
Sideways? Okay. I think what was occurring to me as I wanted to illustrate that was we have our quarter scale track pieces, which are fun. And I was about to cut out a full scale pieces of track as well, just to get a physical feeling of it. It would be really cool too to just go to a print shop and print out on a plotter.
Mm-hmm.
This is the layout of the cell and just 1-to-1 scale. I think that would be really helpful. So maybe that's something we could also have ready for our pitch meeting next week, because it would you really start to get that it's real. I don't know who else out there has had the experience of drawing something in CAD and then you cut it out on the machine, or you mill it and it comes back and it's either way too big or way too small because you've just been looking at it in CAD world. It's easy to lose sight of it. We also had our Carl 3D CAD model as a comparison, so we should put that into our model as well, just so that people have an idea of how tall a human is. And they have a relative proportion of a pair of Keens to compare to the track. So, okay, let's have donut break, because if your blood sugar is getting too low. So I missed this in the intro. Let's just do a quick. Let me see. Where can I get this? Today we've got Voodoo. Hold on. Okay, they're gonna fall over a bit. Oh man, they smell good.
Thanks, Voodoo.
Okay, that was lovely. Voodoo donuts. Donuts are actually bad for you, so I'm going to only have a half one. Do you guys want one, or are you good?
I'll have that half.
You'll have the other half?
Yeah.
Oh, sharing is caring. Okay. So a word about Voodoo donuts. They're kind of the tourist donut. Normally, I wouldn't be seen with a box of these because there are much cooler donuts in Portland. But, we're cycling through. So thank you to Blue Star, Cocoa, Spielman's bagel, not a donut, still full of carbs and also delicious, and Voodoo. So I think there's other ones that are still in the backlog, and if you want to give us donuts, please give us donuts or other treats, because it's part of the fun. Look, enjoy these sprinkles. Let's wait for the autofocus. Come on, autofocus. There we go. Get a good look at that. Oh yeah, donuts and robots finally happening. Thanks, Micah. Oh yeah, that was good. Just a minute. Moment of silence.
We got a commenter from Denmark who loves Voodoo Donuts.
Loves Voodoo Donuts?
Yeah, it's good.
Denmark, see? Yep. Shout out to Denmark, man.
They get it.
They really do get it. They get it so hard. We should live in Denmark, or Denmark should live here. Welcome, Denmark. That commenter probably rode their bike to work in the snow today, which I would also appreciate. Okay. Let's look at our agenda. It says here Nathan controls architecture. So Nathan, do you want to take us through?
Sure.
You've been putting some parts together. Look at that. Nice swipe. Good transition.
Thank you. So,
Oh boy. It's come up. A loop on a loop. It's finally happening.
there was originally 2 loop logos in here, and that was just too many
No,
loops.
that was too many. Sorry, Nathan. Please go ahead.
So this is the main loop, and then this is the divert loop.
Okay.
They're controlled via Ethernet power link. The main controller is this automation PC. This should be at least a 2-slot. APC 910 is the model number for our purposes. We're probably going to go with a 5-slot just so we have some expansion room. This is a Ethernet PowerLink hub that also has a X2X interface on it, so we can connect these power supplies via X2X.
Need that juice. What voltage those power supplies put out?
They'll put out up to
roughly and direct or alternating.
So they put out
Sorry.
they put out 60 volts DC to power
60.
the track.
Okay.
These particular power supplies are capable of putting out 80, but we need to limit it to 60 because the track can't go higher than 60.
Yeah, cool.
There's a safety controller that communicates via ProfiSafe to the robot. And it also communicates via PowerLink to the APC 910.
Cool.
I've got a 21-inch multi-touch display to use as an HMI. And one thing I didn't show here is I also had an e-stop panel with some buttons.
Cool.
So.
And then an ABB robot with an IRC5.
And an ABB robot with an IRC5.
Cool.
So we only need basically 2 PowerLink drops for the track, right? Is that what you're showing there?
Yes.
What's the maximum number of segments that?
You can have a hub depth of 10. So you can feed in the middle, and then as long as, from the controller through the hub to each of the nodes, and each segment is a node, as long as the hub depth doesn't exceed 10, you're fine.
Cool.
There's around the divert section, there's some considerations for hub depth. They need to be plus minus 2 levels on adjacent track sections.
Yeah, and I want to emphasize too, Nathan has shown this kind of, whenever you see these architecture diagrams from really any vendor, they're just, there's just a line here. Never mind that's actually 20 lines or, and this is not that exaggerated in terms of kind of how straightforward it is to daisy chain them together. There are considerations, no doubt about it, but a lot of the track sections can daisy chain their power and their Ethernet, so and they're kind of fully contained units. They just have the plugs on the back, the amplifiers are inside, they just take in power and networking, and you kind of string them all over the place to fly the shuttles around. So that would be a cool thing to show too. What actual connections there would be, maybe in the pitch deck, or just to give a good impression of that, or put some maybe there's just photos of that we could include.
This is definitely a work in progress. There's a couple changes I want to make to it already. But,
nothing like an audience to uncover those.
So any more comments or questions about this before I go to the next slide?
I would like to discuss, we've been playing around a lot with this combination of ABB robotics and BNR. There's commercial reasons, there's technical reasons. What are your thoughts about how we should be running the robot software? And the two that occur to me are the BNR system controls everything about that robot and streams it joints over EGM, or there's some machine-centric approach that is incoming that we could use. Or we could just fire triggers at it and look at where the robot is. Do you have any thoughts or advice on how, what that interface would be, what the right way to be would, or what the trade-offs would be?
So currently with the currently available products with the IRC5, we can do EGM, which could have some advantages. We might be able to move the robot while we're picking.
Yeah.
So we can basically gear into the track shuttles.
Mm-hmm.
Same thing with the machine-centric robotics, which is upcoming. In that case, this controller would disappear, and we'd be controlling the arm directly.
Mm-hmm.
So since we're controlling the arm directly with the APC 910, then again you can gear the axes together and do some interesting things. For the visualizations that we've had, and the timing studies we've done, the shuttles are stopped when we're picking them. So in that case, just trigger signals are all we really need. We aren't really gearing into anything.
Handful of milliseconds to 100 maybe 100 would be too much, but like 20, 50 milliseconds, no big deal.
Yeah.
I think I like that approach a lot too. In thinking about it over the last week or so, the idea that the benefit of doing it with the IRC5 would be you have an entire robot studio set up. All the service and commissioning is really easy. You just and basically it's so simple the interfacing between the two, and we can read the position of the robot really at a really high frequencies, still via EGM, by just trigger it, do its move and its programming. So there could be this interesting hybrid where we're mostly using the IRC5 in a robot studio way, but we're getting feeds of the information. And I also don't know if there's no reason we couldn't do both of those in the same machine, or like sometimes it's EGM, sometimes it's like conventional robot programs.
This hardware diagram, nothing changes between using EGM or using just digital signals.
Just Ethernet signals. Yeah, cool. Yeah, right. That's awesome. And we've done a lot of work in that area, just connecting BNR controllers to ABB robot controllers and just doing everything over Ethernet. The cool thing about that is the same setup can run in the simulators as it runs on the real machine, so you can really do a lot of testing and all the development offline before you have things built, which maybe would be a good transition to our next topic. But do we have anything else before we move on from this? Anything else we want to talk about here?
I don't think so.
Okay.
I guess I could point out the display is a pretty nice display. We have one over there. It's not powered on right now, but it's
here it is. Between my fingers. It's right over there. You can see a picture of Carl installing that and then Nathan reinstalling it. There's some classic YouTube videos from last year of us working with SDL. And any more to add on that? Swing arm.
So yeah, this the plan was SDL4 for the APC 910 to the display. That transmits the display and the touchscreen information via a single Ethernet cable.
Cool.
Instead of needing to use a like a DVI or HDMI type cable, so it's a lot easier to run, a lot smaller.
One thing that we were talking about in Slack about whether we should have an HMI at all, whether we should also have some wireless AR, iPad Pro. Yes, definitely we should do all that. One of the demos that I saw, I think it was at ATX a year ago, it had the shuttle, was flying the shuttles around, and it was on a kind of a flat table, but then it had a swing arm HMI kind of mounted from the bottom. So like if you can imagine the plate that the track pieces would go on, it had the post kind of coming off of that and like doing like a bend, and then it was just on a swing arm, so just kind of like out in space in front, like kind of in front and around the machine. Just talking about it mechanically, that might be something to consider, especially now that we have this other divert loop. There might be like a corner or an edge of the machine where we could tack on swing arm mounted display that's kind of mounted on like almost like a pedestal style, and we could get some stuff that would do that really nice.
Yeah.
Okay, it's 10:30. Anything else to add on this, and we can wrap up and talk about what do we want to get ready for next week. Next week is the big pitch meeting. We want to have everything ready to go, so let's talk about what do we need to get done and who's going to do it, and so that we're ready for next week. Next week, the stream will be on Tuesday morning again. We're going to be kind of rehearsing, and we want to have everything ready and kind of almost do like a quick review, so that we have another 48 hours to do any last-minute prep or any little tweaks before kind of do the official thing of the presentation of this concept. So what I have on the list, besides finish that pitch deck, and we can just coordinate on the fly about that. I'd like to see a little more on the infeed with the kind of different combinations, either the candidates for the infeed, a more complete list that has imagery behind it, or what we talked about was maybe there's just one concept that combines all of them. So getting to a here's the possibilities for infeed, I think, is the one of the biggest open items in my mind about what would we put into the CAD model. And then finishing the deck. Is there anything else besides that unified CAD and infeed that we feel like is a major undertaking? What do you guys think?
So we'll need to get the pieces actually ordered, and there's some mechanical design to do for the track mounting base,
Yeah.
as well as the robot end effector. There's a lot of details to work out before we actually build a complete machine.
Yeah, and I think we should talk about that because what I forgot to include on our agenda is, and we can talk about it for maybe 5 minutes. We should wrap up pretty soon. What is next, right? Like, and we had talked about, we have sort of a shorthand for it last week when we started realizing how many weeks were until our open house, which is April 23rd. You heard it here first. We thought, oh my goodness, that's only 8 weeks away. Like, and so everything changed and downshifted. We're like, oh my God, we got to go at this as fast as possible. My feeling is we don't have enough time to complete the mechanical design, buy all the parts, bring them together, assemble them, integrate them, make them do what they're supposed to do in those 8 weeks. So, I mean, I'm not saying we couldn't. I mean, we probably could, but like that's just maybe more aggressive than we want to be given our day jobs. So what we talked about was what we would normally do, together with our clients, is do a really detailed digital twin, a really detailed model of the machine, and that's what we should be working towards. And again, not for the next week or two, but season 2 maybe. Let's build that detailed model. Let's take this concept and actually try to prototype it in software virtually. Let's see what we learn from that before we start cutting metal or thinking too hard about how to build mechanical adjustment footings and that kind of thing. So maybe I'm just repeating what we already talked about. Does that make sense to you guys? And in which case we can defer a lot of the details of the plate. We just need still the cartoon version of the mechanics so that we have a model of the machine to drive around, not something that we would hand to a machine shop necessarily. So that might, and we can work on the details and mechanics maybe on season 2 as well, in addition to the digital twin. But I would say let's try to get what we would need to do the digital twin, whatever that is. And I think that's more of a cartoon, and maybe we put the HMI in a post and kind of try to get the cartoon mock-up of it pretty detailed, but not cutting metal detailed. Okay, I was just talking a lot. Do you guys have any thoughts about that?
I think that's a good plan.
Any other boundaries or any other things we should include in that?
So the digital twin is interesting because it's really the software that's running this whole thing.
Yeah.
So once that's done and working, the majority of the software is ready for an actual machine.
Yeah.
Depending on the level of resources, we could be doing the digital twin work concurrently with the mechanical design.
Yeah.
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 I think so.
That I think that's a really good idea. And we'll have to ponder who we put on the project for season 2, because we could do a lot of mechanical details while we're building and testing, and for those who aren't paying attention or hadn't had this feeling, like we build the complete software of the machine sometimes before the mechanics are even finished being designed. And that really helps a lot because software is really complicated, and when you learn things from your software models that can change mechanical design, it saves a lot of time and money, and you don't have to throw away as many parts because they're wrong, and you don't realize things right before the machine is supposed to ship. So it's better quality of life and better economically. So it's a good idea all around. Okay, so follow-up. So I think we should be specific. I think we have some work to do, and let's just divide it up and assign it. So who feels better about doing the unified CAD?
I can do that.
Nathan's got that. Do you want to do the pitch deck?
Yeah.
Okay.
That sounds good.
And yeah, I think that's it. you'll be lead on pitch deck. You can create all the assets, and you have the bombs and stuff that you can provide to him.
Mhm.
You guys work on that together, however it makes sense. But
Cool.
we want to follow that template that we do for the new template that we have for new machine concept,
Yep.
and really focus on just the highlights. And I can work on the why slide in the beginning because I know that was something that we had to clarify a couple weeks in. Okay. I think I feel good about this. Anybody have any other stuff they want to cover before we go? Thanks to Denmark for joining us. Thanks to anyone else who's watching on the archive. We'll catch you next time. Thanks a lot. Bye, everyone.
See you.